So we're going to start looking at a graph for two categorical variables. So I'll say draw a graph of, let me just look at the data set again now. Star Wars, where are you? Okay, so there is height and there is mass, right? Okay. So draw a graph of height and mass from the Star Wars data set. Okay. So height is a numerical variable, mass is a numerical variable. So we're dealing with two numerical variables here. And we said the appropriate diagram for two numerical variables is what? Is a scatter plot, right?
Yeah.
So it's a scatter
Yes.
plot. So it's the same principle. So now we will have our ggplot, right? Our data is still equal to Star Wars, okay? And then our mapping. Now, this is where we will now have something on the x-axis and something on the y-axis.
Okay.
Now, when you're drawing a graph that has something on the x and y-axis, usually you have the independent variable on the x-axis and the dependent variable on the y-axis.
Yep.
So x-axis is independent, y-axis is dependent. So you need to ask yourself each time you're drawing a graph of two numerical variables that which of the variables is the independent and which is dependent, so that you can know which variables to put on the x and which variables to put on the y. Okay. So between age and height, which one is likely to depend on the other? Sorry, height and mass, or height and weight. Which one do you think depends on the other?
Height is more likely to be the independent.
Exactly. So mass will usually depend on your height. The taller you are, it's more likely the heavier you are. Right? So our mapping will be aesthetic. So that tells us that since the height is the independent, that means x will be equal to what? Height. Right?
Yeah.
And then y will be equal to what?
Mass.
Mass. Exactly. So we will now put our plots. Remember, this is ggplot. Instead of pipe operator is plot, is plots. Then our geom. What geom are we using here?
Scatter plot.
No. What does R call scatter plot? It calls it point.
Well, okay, point.
Don't worry, you get used to it. Because a geom point, right? So if I do this, Control Enter, so you can see the graph it gave us. You can see the points, right? But it's as if everything is crowded towards this down part. And the reason is that, can you see where my pointer is?
Yes.
There is this outlier in mass. You can see all their masses are between like 100 and 250. But there's somebody that has a mass of more than 1,000. And that's why it has shrunk all the rest of the points to this. So if I wanted to eliminate that guy as an outlier, what I would do is to create another data set without him. So I'll say, let me call the new data set Star Wars 3, for example, and then I will assign it to our Star Wars, and then I will filter only those whose mass is less than 250. Okay. So what I'm saying is that I want a new data set frame, a new data frame for which the mass is, you can see from this graph where my pointer is the 250 mark. And none of them is above this 250 except this guy. So I'm just going to remove this guy by saying I want only those whose mass is less than 250 so that I'll have a better graph. So if I run this now, and then I come to this place and replace the Star Wars with Star Wars 3, and then I run this, you can see the graph is a bit better. Right?
Yeah.
Now that's 1,000 guy of mass has gone. So you can see the graph is a bit better. Let me zoom it so that we can see it better. So you can see the map. Let me escape to the map graph of the relationship between height and mass. You can see there's a semblance of a linear relationship. As height is increasing, mass is also increasing. Right?
Yeah.
Okay. So the same thing we did up, we can also beautify this. We can say we want the maps to be. So now there's a difference between, you know, when we are dealing with bar chart and histogram, we used fill because those ones have like a holo, right? Now a point does not have a holo. Does that make sense?
Yeah, it does.
So what color was doing in what's it called? What color was doing in histogram and bar is what color will do here. So to color the points, it will just be, we use color, not fill, because a point does not have a holo for the color to fill inside. I don't know if that makes sense to you.
Yeah, yeah.
So in Jom point, we don't use fill because there's no holo to fill. Rather, we just use color equal to, let's say, red. So if we do that, it changes all the points to red. Can you see that?
Well,
is it visible for you?
It's visible.
Okay.
Can see.
Now, remember we said yesterday, if you are mapping to a general color, it's sorry, if you're mapping to a variable, it has to be inside what?
You see, I don't get that.
What's the difference between mapping to a general color and mapping to a variable? We discussed that yesterday.
Did we?
Sorry?
I'm trying to remember.
Okay. So I'm going to copy this code again.
Okay.
While you're remembering.
Is this something to do with the static and dynamic mapping?
Yes, that's what I'm talking about. So what's the difference in terms of the code?
I can't remember. I didn't watch that, please.
Okay, so we said if you're mapping to a variable, it has to be inside an AES.
Okay.
you remember. So here we wrote just color equal to red. But if we're going to map it to a variable, let's say color equal to gender, so that you see these points in terms of splitting it by masculine and feminine, we will no longer write just color equal to red. It will be color equal to gender, but it has to be inside an AES. So I'm going to cut it. So within the join point, I'll write AES, open its own bracket, and then I'll paste the color equal gender. So can you see the difference between this one, where I did only color equals red, and then this other one, where the color equals gender?
Yes.
So this is inside an AES because we're mapping by a variable, whereas this is not inside an AES because we're mapping generally.
Wow.
This is the static mapping, and this is the dynamic mapping. Okay. So if I run this now, so if you look at the diagram, it has mapped the points based on gender. You can see the orange ones are female. The blue or green ones are males. And then there's also the one with missing value for gender. Now, because the points are very small, I can want to increase the size of the points. So after this, I can say comma here and say size equal to 2, for example. So that means it should make the points 2 times their size. So if I run this now, let me make it bigger so that you can appreciate it. Let me say equals to 4. So can you see the sizes are now bigger? They are now 4 times what they were initially.
Yeah.
If I zoom it, you can see the sizes are bigger now. Yeah. And then the color is based on the gender, rather than the one that was just everything was red, just to color the whole thing red. Does that make sense?
It does.
Okay. So that's 2 numerical variables. Okay. Now the next thing is for us to now see a combination of numerical and categorical variable. Okay.
Yep.
So what do we say about a numerical and categorical variable is that when you have a numerical and categorical variable, you draw the graph of the numerical variable and then you disaggregate by the categorical variable. So let's assume now we want to draw graph of height and gender. So because there's a numerical variable here, we will draw the graph of the numerical variable. So the numerical variable will be ggplot, right?
Yep.
Then data equals Star Wars. Mapping equals AES. X will be equal to height. That's for the numerical variable. And then plus our geom will be let's use a box plot.
Okay.
Because say one numerical variable can either be a box plot or a histogram, right? So now this is the graph of the numerical variable. If I plot it, I have a box plot. Can you see the box plot? Now, because we're now saying we should also combine with a categorical variable, we now have to disaggregate this by, so here we put comma, on our y-axis we put gender. That's one way to do it. So if I run this, you can see it has disaggregated by gender. Here is feminine, here is masculine, and here is the one with missing data. Sorry, with missing gender, missing value of gender, right? So it has disaggregated the numerical plot by the values in the gender. So this is what I mean by when you have a numerical and a categorical, you draw the graph of the numerical and then disaggregate it by the categorical. Does that make sense?
It does.
Okay. Another way you can do this is to use the fill. So I'm just going to copy this. I will remove our y equal to gender. And rather inside our join point, I'll put my AES. And I'll say fill equals gender. So if I run this, it still does the same thing, but this time around it's filling them with colors of the gender variable. Does that make sense?
Yep. Right.
Yeah. It might seem a bit confusing, but the more you the more you run the codes, the more you get used to them.
Yeah.
Yeah. Okay. So this is basically our
I'm
data.
just looking at the I'm just looking at the y-axis. I'm trying to make sense of the numbers that are there. The minus
Okay.
0.
I haven't really looked at that because
Right.
in the other one, it actually gave us male, female, and okay. Sorry, let me see something. Let me see if I add y equal to gender here. Let me see what happens. Okay. Okay.
Okay.
So it's still the same code. The only difference is that we now added fill equal to gender within the join box plot.
Yeah.
I think it's better this way.
Yeah.
Instead of the one of 0 points or something. Yeah. So this is the 5 different plot types. You have single categorical, single numerical, 2 categorical, 2 numerical, and then a combination of numerical and categorical.
All right.
So most of all the plots, all the graphs you plot will follow this pattern.
Yeah.
Yeah. Any questions so far?
No, I think I'm following.
Oh. We have a few minutes to the end of the session. So if you don't have any question, we'll end here and get back in 10 minutes.
All right.
Yeah.
Okay, I'm just seeing, like, for us, many of the analysis that we will do using this will follow this type of graph because most of the work that is done is grouping, giving treatments, and then let's say different doses of treatment, and then
Okay.
taking data. So
Okay.
it's like we'll follow this pattern, but instead
This
of
one of
gender,
a
the different
combination of categorical and
yeah,
numerical.
and numerical, yeah.
Oh, okay. Makes sense.
Yes.
It's fine.
Okay.
Okay, we'll get back in 10 minutes.
All right.